More multiplying and dividing monomials rules, part 2. So we're just going to go over a couple more rules. The first rule that I want to review with you guys and show you is 0 as an exponent. Anytime you have a number or a letter raised to the 0 power, your answer will always be 1. So I would like to look at an example. So here I've got x to the 4th power times y to the 0 power is all divided by x. So the first thing that you have to look at is this exponent for the y raised to the 0 power. That just becomes 1 because that is our rule. So when we rewrite this, what we have is x to the 4th times 1 all divided by x. You're most likely going to ask, do I have to put this times by 1? No, you don't. I'm just showing you that that's what that simplifies to. So then you have x to the 4th over x to the 1st. And you're dividing exponents with bases that are the same. You're just subtracting these exponents, so you get x to the 3rd is your answer. Another possibility that might happen is you might get a problem that looks like this. So you've got these two letters being multiplied on the top, raised to the 0 power, all divided by y. Well, we know by our rule, if you raise anything to the 0 power, it's going to be 1. And then the y just stays in the denominator. So your answer in this case is 1 over y. Be sure when you're simplifying, you watch out where you're putting your 1's, because if you gave me an answer of y, that would be incorrect. So be very careful with these problems. Okay. Next we're going to look at is what happens if we have a negative exponent. Basically, you're going to move that particular monomial either below or above. So you're looking at that particular, whether it's your base that you're moving down, it's the whole monomial, depending on how that works. So we're going to go through a couple of examples in a minute. So if, for instance, we just had a simple x to the negative 2 power, we always know that if we have a whole number, it's always written over 1. So what happens is this negative 2 makes it drop down to the denominator, and they basically switch places. So whatever's in the denominator is now going to be in the numerator, and so forth. So in this case, you're just going to have 1 over x squared. If you had something like the following, and this was all raised to, let's say, the negative 1 power, this flips it. Okay, so AB goes to the top, XY goes to the bottom. So whatever is in parentheses raised to that negative exponent, that needs to move either, if it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. Okay. Next one. So here we've got, this AB is raised to the 2nd power, the negative 2nd power. So this means it's going to be moving down to the denominator. This a squared that's in the denominator, yes, is going to move to the numerator. So let's deal with those particular variables first. Now you've got to deal with the fact that you've got a b to the 2nd power. So that means that a is squared because of the power of power rule, and then you've got b squared times b to the 4th. So basically you're distributing this power, and we'll look at another example of this in a minute. We then simplify. So I'm going to leave the a squared numerator. You got a squared in the denominator. B squared times b to the 4th is b to the 6th. Now I look here and I've got a squared on the top, a squared on the bottom. Those cancel out. So now I'm left over with 1 over b to the 6th power. Here's another one. Now with this particular equation, what's going to happen is, because the denominator is all raised to the negative 1st power, that means this, the s squared t cubed, is going to move up, and then this s to the negative 3 moves to the denominator, and t to the negative 4th moves to the denominator, making those exponents positive. next thing I look at is the exponents. So I look at the bases. I've got s's on the top and the bottom. I know I have more s's on the bottom, so when I subtract, I'm going to have one s on the bottom. Then I look at my t's. Again, I have more t's in the bottom, so I'm going to leave the extra t's in the denominator. So I go 4 minus 3 is just 1. So now you've got this 1 over st, and that's your answer for that. Last one. Now, these two rules, the power of a power and the product of a power, we did one example in that last slide that kind of talked about this. This whole power, this ab to the second power, what that is just distributing that 2 to the powers that are already there. So let's talk about that in a second. And then you have another one where you've got a power to a power, right? So we just talked about the product power, that you're just going to multiply those powers. So let's look at a couple examples. So let's say we have, let's go 2x squared, and then in the bottom we'll do x squared, y squared, all raised to the third power. So first we need to distribute that 2. So I already have 2 to the first power, so now it's going to be 2 squared. And then it's going to be x to the first times 2. In the denominator, it's going to be x squared times 3, because I'm multiplying that 3 on the outside of the parentheses with a 2 inside. And then you've got 2 times 3. Now you simplify. So 2 squared is 4. X, when I multiply, it'll be x to the second power because it's 1 times 2. Denominator is going to be x to the 6th, and then it'll be y to the 6th. You then look to see if you can simplify anything. I've got 2 x's on the top, 6 on the bottom, so when I subtract those I have 4. There's more in the denominator, so I'm going to leave that there. So 4 will be by itself on the top. It'll be x to the 4th, y to the 6th. Alright, at this point, this concludes the examples I would like to go over. You will have more practice.